When you look up at the night sky, almost everything that you're looking at isn't really there, at least not in the way that you think. See, 95% of the universe is made of something that we can't see, can't touch, and for most of human history, couldn't even prove it existed. We gave it names like dark matter and dark energy, but a name isn't an explanation. It's just a placeholder for something that we don't understand yet. And in a few weeks, NASA's about to launch a telescope that is built to go looking for the invisible. This is Look Up Tonight. Let's get into it. For decades, astronomers have been hunting the universe's biggest mysteries with some of the most incredible machines that we've ever built. We have Hubble, James Webb, and dozens of telescopes on the ground. But here's the problem. Hubble is almost 30 years old now, and James Webb, for all its power, can only stare at one tiny patch of sky at a time. In fact, Webb's field of view is so small that it's like trying to map the Earth by looking through nothing but a drinking straw. But on August 30th, that's all about to change. NASA is launching the Nancy Grace Roman Space Telescope, and astronomers are hoping it rewrites the rules for how we search for answers about the universe. This could be one of the launches we're still talking about decades from now. So let's talk about how it may change what we know about gravity, the fate of the universe, and whether we're alone in it. So what is Nancy Grace Roman exactly? It's NASA's newest flagship telescope, the product of over a decade of work from more than 1,000 scientists and engineers. It's built to tackle dark energy, exoplanets, and the evolution of the cosmos on a scale nobody has attempted before. Look, I've been chasing this stuff since the 3rd grade when my parents helped me mold together a model space shuttle for a school project. And since then, science has come a long way, but not nearly enough to answer the questions that actually keep scientists up at night. Like, what is dark matter? Why is the universe expanding, and how is that even possible? And how many other worlds are out there? And Roman is going to attack all 3 of these questions by scanning the sky in a field 100 times wider than Hubble's and doing it 1,000 times faster. Now, maybe you're wondering why any of us should care about a $4 billion telescope sitting a million miles away, somewhere none of us will ever see. Fair question. My answer? Simple. This can change everything we know about the universe. But first, let's talk about the tools that we have now. Think of Hubble as our photographer. Gorgeous detail, narrow frame, deep zoom. It's been doing that job since 1990, which in telescope years is ancient. You're not watching this on a box TV from last century. You've probably seen this image before, the famous deep field. One of the most iconic photos ever taken. Hubble had to stare at one tiny pinprick of sky for 11 straight days to capture it. Roman could shoot that same photo in only about 15 minutes. And James Webb, meanwhile, is our detective. It doesn't scan, it investigates an extremely narrow field of view that can see impossibly far into the infrared. The problem is the same one Hubble has. It's still just a tiny fraction of the whole picture. Brilliant detail, but almost no width. So Roman isn't here to replace Webb, it's replacing Hubble and pairing up with Webb. Roman sweeps wide across huge stretches of sky, and when it spots something worth a second look, Webb can zoom in. This is a brand new duet of the cosmos that will study everything we can and can't see. So what actually is dark energy? And honestly, we don't know. That's the whole mystery. But what we do know is that something's pushing the universe to expand faster and faster. But we don't know what or why. And Roman is going to hunt for that answer by looking at the light that bends around massive clusters of matter. Think black holes and clusters of galaxies. This is something called weak gravitational lensing, and it lets scientists map where matter is, including the invisible kind, and how that's shifted over time. Combine it with galaxy positions and distant supernova, and you start to get a timeline of the universe's entire expansion. If all of those methods agree, we're finally close to an answer. If they don't agree, then that's where we start rewriting what we think we know. And then there's the hunt for other worlds. We found over 6,000 exoplanets so far, but most of them are scorched, oven-hot worlds hugging close to their stars. Not because that's what's actually out there, but because that's what our tools are good at finding. We spot planets by watching stars dim as something crosses in front of them, or wobble as something tugs on them. And both tricks work best the closer a planet is to their star. But Roman is going to try something stranger. It will stare into the crowded heart of the Milky Way and watch for 2 stars drifting in front of each other, allowing the nearest star to act like a magnifying lens of the star behind it and allowing us to see planets we can't with Hubble. This is something called gravitational microlensing, and Roman can catch it. And because this trick doesn't care how close a planet sits to its star, it can find worlds nothing else can. planets on wide, lonely orbits, and even planets with no star at all, just drifting alone through the dark, otherwise invisible to us. But the bigger story here isn't the planets themselves, it's the pattern. Up until now, we've studied planets one at a time, like walking through a forest finding a single tree and studying it branch by branch. Roman is going to fly over the whole forest and draw the map. Instead of asking questions like, is this one planet habitable? We're going to be able to ask questions like, how common is a solar system like ours? Are we the rule or the exception? And the answer could change how we view the potential for habitable planets and alien life in the galaxy. And honestly, the most exciting part of this mission might be the thing that nobody's expecting. So when Roman finally launches, remember what came before it. Hubble has given us the detail, and Webb is showing us the deep infrared past. But Roman is going to do something that neither of them can, which is to watch almost everything, including what is currently invisible to us, and let us see what sticks their neck out at us. We still don't know what most of the universe is actually made of, and we may not for a long time. But on August 30th, we're sending something up there to go looking. And if the last 100 years of astronomy have taught us anything, it's this. The discoveries that change everything are almost never the ones we expected to find. So that's all for this one. I hope you enjoyed today's video, and if there's anything that you ever want to explore together, let me know in the comments. Thanks for watching, and as always, don't forget to look up. See you next time.